Okay. So the question, page number 93, question number 1, mention the advantage of selection of pea plant. Pea plant, when we discussing about the Mendel's experiment or success of the reason of the Mendel's success, we said selection of pea plant was the one of the most important factor. Now what is there in the pea plant? The pea plant has several advantages. First of all is that the short lifespan. The pea plant could finish its lifespan either in 4 to 6 months time. So 4 to 6 months means within 4 to 6 months you get the seeds for the next generation for the next experiment. So in a year at least 2 experiments we could conduct. At the same time, if suppose someone is conducting experiment on cows or a sheep or an elephant or something else, he will have to wait longer in order to reach the maturity, sexual maturity, and then undergo the sexual process and have the babies. Second advantage, the peas have large number of offspring. So each pod itself has got 5 to 6 seeds, and you can have number of experiments, so number of seeds could be produced. Third is the pea plant had 7 pair of allelic characters, which was noticed by Mendel. Mendel noticed there are 7 pair of allelic characters were there. What were there? That is the height of the plant, tall and dwarf, color of seed, the yellow and green color of pod, green and yellow color of flower, purple and white, shape of seed, round and wrinkled, shape of pod, that is inflated and constricted, and position of flower, that is axial or terminal. So that was again, now the flower itself was bisexual flower. In pea plant the flowers are bisexual flower. Bisexual flower has another importance, that is you can make any flower as male or female. So in having number of experiments, you can select, suppose you got a tall plant and a dwarf plant. In one of the flower you can consider as the male, and the other flower of the same plant can be considered as the female. So vice versa, the reciprocate experiments can be easily done. So these were several advantages which were there in the pea plant. Moreover, we are studying, or that is Mendel studied in the Austria. Austria is a cold country, and there pea could be grown throughout the year. So that is how the pea plant has several advantages. Okay. Question number 2. Differentiate between following: dominant and recessive. Dominant character are those characters which are seen in the F1 generation. If we take a cross between pure, tall and pure dwarf plant, in F1 generation we get all tall plants. Now why only tall plants are seen? Because the tallness is dominant over dwarf plant. So this is why the dominant character are those characters which are more frequent, which are dominating over the recessive character, which are, that is when a pair of pure contrasting characters are taken, the number of the F1 generation only they are seen. In F2 generation you will get more dominant character than the recessive character. Okay, now recessive characters are those characters which fail to express themselves in F1 generation if a cross is done between pure contrasting character. Next is homozygous and heterozygous. Homozygous condition is one, both the alleles of a character are identical, capital T, or small t, or capital R, they are homozygous condition. Or in simple language, that is in the day-to-day language, we can call them as pure plant. Whereas if capital T and small t is there, or capital R, small r there, then these are heterozygous condition or hybrid plants. Okay, so that is heterozygous. Next is monohybrid and dihybrid cross. Monohybrid cross is the one in which only one character is studied at a time. Now I said, or rather Mendel found that there are 7 pair of allelic characters present in pea plant. Now out of the 7 pair of allelic character, when he consider only one character at a time, such a cross is called monohybrid cross. Suppose he has taken a plant, tall plant, and has taken another dwarf plant, both the plants are pure plant. That doesn't mean it never had a flower, or it doesn't have seed, or it never had seed color, or it doesn't have seed pod color, etc. All other characters were very well present there, but Mendel did not consider them for his experiment. For his experiment, he considered only and only one character. And when a cross is there in which only one character is studied at a time, such a cross is known as monohybrid cross. And if we consider two characters simultaneously, such cross are known as dihybrid cross. So monohybrid and dihybrid is dihybrid, that is in a plant there are 7 pair of characters are there, but out of them he is considering or he is studying or he is studying only 2 characters, then it is called dihybrid. Okay, question number 3. A diploid organism is heterozygous for 4 locations. How many type of gametes can be produced? Diploid means there are 2 factors. Now a plant with the 2 factors and all those plants are actually heterozygous, as it is written heterozygous for 4 locations. In fact, I can say that actually we want to say that capital A, small a, capital B, small b, capital C, small c, capital D, small d. 4 pair of characters are there. And now 4 pair of characters, there are 4 pair of alleles. How many type of gametes it will form? So they will form altogether 16 possibilities. The formula is very simple. The formula is that is the number of location to the power 2. So 4 to the power 2, that is 16. You just want to do this thing, do yourself and find out. You see capital A, capital B, capital C, capital D, capital A, capital B, capital C, small d, capital C and small d, capital A, capital B, small c, capital D, capital A, small b, capital C, capital D, small a, capital D, capital C, capital D, and like that. Now they are here we are taking only 1 recessive and 3 dominant. Next experiment, next condition you take 2 dominant and 2 recessive, then 3 recessive and 1 dominant, and 4, that is then all 4 of them are small a, small b, small c, small d. All together you will get 16 possibilities. Okay. So the simple formula you remember, you need not to work. Okay, very well. So you need not to work out the whole thing, but you have to just consider the formula and your answer will come. Explain the law of dominance using monohybrid cross. When I was telling the question number 2a, I explained it. Okay. So our question is, that is explain the law of dominance using monohybrid cross. Monohybrid cross you can explain by considering a pure tall plant and pure dwarf plant. The genotype is there, pure tall and pure dwarf. According to the second law, that is the factorization is there, these factors will segregate, segregation of factors, and the factors go like this. Take Newton's square. These 2 factors you take here, these 2 factors you take here, capital D and small d, capital D and small d, capital D and small d, and capital D and small d. So in F1 generation we get all the same type of genetic combination, that is capital D, small d, and all these plants since they had capital D dominant character, so they all will be tall. So this is how the law of dominance can be explained. That is, when a pair of pure contrasting character is taken in F1 generation, only one of the trait visible, the other trait is hidden. The visible trait is called dominant and the hidden trait is called recessive. Okay, any doubts? Okay. Now question number 5. Define and design a test cross. Test cross. As the name indicates, we are testing something. What we are to test? Test cross is the cross in which in fact we want to know the genotype of allelic combination or allelomorph of unknown plant. Now suppose tall plants can be of 2 types, capital T, capital B, or capital B, small d. So there are 2 type of combination, 2 type of possibility of having tall plants. Now we have got a plant. We can't see that what type of genes alleles are not visible, but only the factors are visible. Factors are visible, or rather we can say phenotype is visible. So phenotype, like the tallness is there because of this combination or because of this combination, that we have to find out. How we will find out? It's very simple. What we have to do is we have to cross it with the recessive parent. So we make a line here. This side we are taking, suppose this type of condition is there, and this is the recessive parent, and this side heterozygous condition is there and recessive parent. The factors form is the condition 2, condition 1. Factors form capital T, capital T. Here small t, small t. Here capital T, small t. And it will always be small t and small t. इनके बच्चे will always be tall only one type, and इसके बच्चे can be of two types, capital T, small t and small t. 50% will be tall and 50% will be recessive. Okay, so when 50-50 ratio comes, that means the parental genotype or allelomorph was hybrid, that is capital T and small t. And if all the plants in test cross are of same type, dominant type, that means the allelomorph of the parent, the plant which we are testing are homozygous dominant. Okay, so test cross is a cross in which we can find out the unknown allelomorph or allele combination of a dominant character, which can be homozygous or heterozygous. If it is homozygous, in the cross we will get all same type. If it is heterozygous, we get 50% of dominant type and 50% of recessive type. Okay, so that is what the test was. Question number 6. Using Punnett square, work out the distribution of phenotype and phenotypic feature in the first filial generation after a cross between homozygous female and heterozygous male for a single locus. It is something like this. So you can consider this example for the next experiment also. But only difference is we have to take Punnett square. Is it visible? I think it is okay. So we got a plant with the heterozygous condition. I'll read it again. Using a Punnett square, work out a distribution of phenotypic feature of first filial generation after a cross between homozygous female and heterozygous male. Homozygous male and female hardly matter because we are not writing which is male and which is female. We are taking heterozygous and homozygous. Remember, we are taking homozygous recessive here. You can even take homozygous dominant because in question it is not clear. It is a confusing question. Anyway, the two factors we got here, In the Punnett square, you make 3 lines like this, then 3 lines like this, and you get a Punnett square. Both the factors from here you write here. Both the factors from here you write. So capital T is small t. Small t is small t. Capital T is small t. Small t is small t. So 50% plant will get of dwarf type, recessive type, and 50% of plant you will get of dominant type. Okay. So this is what the condition is. Okay. Okay. Question number 7. A cross is made between tall plant with yellow seed. Genetic combination is given here, capital T, small t, capital Y, small y. That is both are heterozygous. And a tall plant Heterozygous tall plant with green seed. So green is recessive. What properties of phenotype in offspring could be expected as tall and green, dwarf and green? Very good. Actually, here is testing our knowledge about the crosses and as well as the genetic. What? X. Okay, so this is capital T, small y, capital T, small t, capital Y, small y. Okay, and they will produce two type of gametes here. There are four type of gametes here. Checkerboard we are making, all the four gametes are there, all two gametes are here. And when we make the genotype, here we see that tall and yellow. This is also capital T, capital Y, tall and yellow. So three we got tall and yellow, tall and green, and tall and green three. Then this is dwarf and yellow 1 and dwarf and green 1. So altogether 3:3:1:1 is whole ratio. Now what is asked in your question? You can see in your question the tall and green was asked, tall and green 3 and dwarf and green was asked 1. Okay, so 7 questions we done, 8th and onwards we'll do tomorrow. Thank you children.